Hi everyone, and my name is C.K. Jane, and I'm going to introduce about the Natural Chapter project that we are working, and I will first to briefly introduce some basics of this project and also the decision supporting tool that we are developing, and then Greg will take over for more details. So the Natural Chapter project is a kind of it's a joint venture program among Stanford University and World Wildlife Fund and the Nature Conservancy and University of Minnesota. And the main theme of this project is ecosystem services that we are talking mostly today. And so we are focusing on the benefits provided by the natures. So you already discussed a lot about the ecosystem services, so I'll give you some examples. So we'll give the benefits. We are interested in the benefits, food from land and also marine systems, and also the renewable energy that we can harness from the nature, and also healthy ecosystems that may provide the opportunities for recreation and tourism, and also a lot of activities with the nature, like the timber production and sustainable fishery that may produce a lot of job markets. So, and these are some other examples that we can ecosystem services from oceans and marine systems. So the Natural Chapter project helps people understand the benefits provided by the natures, and we use that understanding to inform the decisions for conservation and development. So our mission in science, we develop new ecosystem service researches and some tools that we'll introduce today. And we demonstrate viability of ecosystem services, service approaches globally, and we influence the leaders and managers to use this ecosystem service framework for better decision-making processes. So we are composed with diverse members with various specialties. So that includes ecologist, oceanographer that I belong to, and fisheries scientist, geographer, computer scientist, and policy communication specialist and economist. So we all work together for ecosystem service, and we try to make maximize our specialties to reach their goals. Okay, so one of our major goals is to develop a decision supported tool that called INVEST, Integrated Valuation of Environmental Services and Trade-offs. And this tool has some specific characteristics, and this tool should incorporate multiple services, including biodiversity, and also this tool applies scenario-based analysis, and INVEST incorporates both biophysical and economic currencies. And this tool is flexible so that we can apply this tool for many areas in the globe with minimum data set, input data. So, and most important thing is free, so you can play with it. So these are the ecosystem service framework that we apply for the INVEST tool. So the ecosystem service is composed with three components: the supply and service and value metrics. So supply metrics is belong to biophysical domain. And some of the supply that we can utilize, we can enjoy. The part that human can enjoy, that is the service. So the service part is related to both biophysical and human domain. And then with incorporating this social preference, we value this service. Okay, that's all for my part, and Greg will introduce more details of our talk.
Thanks, CK. So our conceptual approach is outlined here. This is mostly focusing on marine systems, where the team that CK and I work on, but it's just an example. It can easily be assumed to be terrestrial freshwater models as well. I wouldn't get bogged down in sort of the details of this, just basically the headings. As Holly mentioned, it's really a scenario-based assessment tool, so we look at both current conditions on the landscape or the seascape, and then we create these future scenarios. And they're not predictions, they're just plausible futures or possible outcomes in the future, and how the distribution and provision of services we might expect using our modeling tool for these different futures. So we feed these scenario inputs along with biophysical and socioeconomic data into our models, which help to look at ecosystem state, function, and then the thing we're all here for, which is ecosystem services. So in terms of carbon, it's carbon sequestered. For the coastal protection, it's avoided area of erosion, recreation, like something like visitation, and aquaculture, harvested biomass. We also, many of our models have the option for valuation. It's not required, but you can, if you have the right sort of information, you can do evaluation with these simple models. So for carbon, it would be the value of carbon sequestered, expenditures due to recreation activity, or net present value of the finfish or shellfish for the bottom two models. And then finally, we're starting an initiative within NatCap to really start looking at units of well-being. And for those of you who have worked in this kind of stuff before, it's probably the most challenging. The provision of the service is not to say difficult, but we've sort of come up with a way to handle that. But looking at actually how the beneficiaries receive these services and the delivery of that service is much more complicated. So things like climate regulation for carbon, shelter for coastal protection, food security and nutrition down the line. And so just flipping these three sort of examples on their side, you can see biophysical examples, monetary examples, and now what we're really focusing on. And actually, some members of our team are meeting in Vermont this week to start really talking about these as a focus, since these are what people ultimately care about. So we have a variety of different service models. You saw from Holly's presentation the different ones that were outlined by the Millennium Ecosystem Assessment. And what I'm showing here on the left is our currently available marine models, which can be downloaded right now for free on our website, as well as our terrestrial and freshwater models on the right. And so today, given that we only have half a day to talk about biophysical, we're going to focus on carbon sequestration from the terrestrial side, and then marine water quality from the marine side. We also have a blue carbon model, which looks at more coastal ecosystems and how they sequester carbon, which will be released shortly. And if you have any more questions, if any of these interest you, I noticed a lot of people mention recreation as their service. We have a bunch of people working on recreation model, which will be part of our toolbox shortly. If you have any questions about that, we have an in-depth user's guide and scientific manual, as well as people who can answer your questions if you go on our website. With Invest, we take a tiered approach, and what that means is it kind of ties back to what CK said about how it's flexible with minimum data requirements. You could use global inputs potentially to map and value ecosystem services. While that's not always recommended, it's useful to have that option where data is, areas where data is poor, so where you don't have a lot of information. So we have these simple tier 0 models that are just relative, meaning outputs are relative to one another, and they're simple to parameterize. They're designed for these data limited areas. They're easy to apply, and they should just be interpreted as first cut estimates in terms of service provision. On the other side, we have these more sophisticated tier 2 models, which are these more complex process-based models designed for areas where you have a lot of data like the United States and elsewhere in the developing world. Take a long time to apply, so this is not something where you can create scenarios overnight and run a model. It's going to be quite an investment to get this information, but they're more reliable and refined in terms of the estimates that they provide. And right now, Invest is kind of sitting in this tier 0, tier 1 side of the spectrum. We're constantly working to develop more tier 1 and then eventually tier 2 models as we continue to develop the tool set. And for those of you not familiar with what a GIS is, it could be within ArcGIS or QGIS. The good news, well, first of all, what you're seeing here is our toolbox as it sits in the ArcGIS platform. And essentially what you're doing is you're feeding information in spatial information where things are located, GIS files, as well as tabular information that links to those files. And then we feed it through our production functions to produce outputs, which you can also visualize as maps in the tool. The good news is, many of you know ArcGIS is an expensive license to acquire. Not everybody has the budget for that. And we've begun a initiative with our software team to make them completely independent of ArcGIS. And the models that we're going to demonstrate today are just that. There are beta tools, which by, I believe, December or early next year, all of our models will be in that framework. But for right now, it's a mixture of half of them you do not need ArcGIS to run, and half you do. And so we're going to demonstrate the ones you don't need it, since we have limited time, and we didn't want to expect everybody to have to install ArcGIS. So that's sort of the future, and we're excited about that because it'll allow more people to have access and use our tool. Real quickly, where we work, our freshwater and terrestrial applications have been going on a lot longer, so you'll notice that they're more spread throughout the world. CK and I work in the marine team. Specifically, we're going to focus today on some of our work in Belize, in Vancouver Island, as well as Sumatra for a case study we're going to show you work through later today. Oh, and then the one other thing is you'll see these linking land and sea. We have an initiative called Cameo, where in the United States we're actually trying to link our terrestrial and freshwater outputs to marine outputs and sort of understand that interface between the two of them. Invest can be applied in a variety of different decision contexts. Here are some examples of that and the geographies in which we've applied them to date. Again, we're going to be focusing a lot today on marine and land use planning in Belize and Sumatra in Indonesia, as well as other options as well. Climate adaptation, we're working on payments for ecosystem services, permitting and licensing, and water funds prioritization. So there's all sorts of stuff going on. Again, given the time constraints, we're going to focus mostly on spatial planning today, but there's other options out there as well. It's very important when you conduct an ecosystem service assessment like this to really get stakeholders involved. Ultimately, they're the ones that you're going to need their input, especially in areas where you do not have a lot of good information. So I found, especially with all of our marine applications, the first thing we do after we start gathering basic data is to work with stakeholders to understand what's important to them, what do they care about in the region. And so this is just a framework developed by our lead scientist talking about how we identify the objectives, develop these scenarios for the future, then we compile data using stakeholders to guide that. We then run our models to create these maps of ecosystem services and values, and then we synthesize results. But it's not just a one-step thing. This sort of process is iterative. I'm sure you've heard that before. We use the results, we bring them back to stakeholders, and we develop new scenarios. We can use a run of a model to understand where we don't have enough information and where we need to gather better information, whether it would just be scouring the web, talking to stakeholders and getting better information about where is that aquaculture facility you want to build, or where do you want to harvest the timber on a landscape. So stakeholder engagement is very important for most of the decision contexts we apply Invest for. And the last slide before we launch into our next portion of this is just some take-home messages. We all know this is why we're here. Nature provides benefits to people. There are many tools available, and just one example of that is Invest. So we're here to show a tool that we work on called Invest, but it's not to say it's the end-all, be-all tool that you use for these types of assessments. Invest is flexible in the sense that you can use minimal data to get results that you want, but it is also portable in the sense that you can use other models and other information to feed into it, or it can feed into other models as well. So it's important to realize that while we're going to be talking to you about what we're working on, there are other tools out there that can also help you achieve your goals, especially if maybe Invest doesn't have a model for that. And so our ecosystem framework can help these various stakeholders I mentioned before access, and hopefully you as well, access these useful tools. So with that, I think it's time to go to our interactive exercise. Is that correct?
Yes. I should have just shown I meant to show a slide for a quick run through of the day, but now we're going to have I don't need to do that. But now I think you should already have them in your packs. There's a Best Coast Belize exercise.
It's just a case study that outlines sort of what we're doing. So I don't know if we need to read through that right now, but later on, if you're more interested in our work in Belize, you can refer to that short case study. So we're going to do an interactive mapping exercise today. Yes?
I had a question about your...
Yeah, actually, I should have stopped for questions. Okay. I apologize. So that was a real quick run-through of what we do, and I'm sure we glanced over a lot of things, and so I'm happy to talk more about it later. We're just trying to push through, but we can have time for a few questions.
Hey, Jess, and this theory points out I should have been clear over here on the novice end of the line, but I was thinking that you would start with a map of ecosystem distributions, ecosystem occurrences, and then attribute those for their production or their value. But I didn't see a map of ecosystems when you listed inputs. I'm wondering about...
Yeah, absolutely. So, for example, we have biodiversity and habitat risk models that we help us model the delivery of services, and so one of the primary inputs would be habitats that are important, within an ecosystem. So, where did you talking about for inputs? Where, like over here?
That one right there, the biophysical.
Yeah. So that would probably go under habitat type. I mean, these are all sort of information about ecosystems, right? So we're modeling coastal protection. We need to know the wave profile. We're monitoring, looking at biodiversity. We need to know species distribution and different habitats that are there, as well as threats. So it's all sort of encompassing as far as ecosystem maps. And depending on whether you're doing a local assessment, like a lot of the work we do, or a sub-global assessment, those maps might be more generalized or spread across, aggregated across a larger area, or they might be very specific as a land cover pixel, which you then run our models for. And I'll go into more depth in terms of how the inputs work as we go through the tool, but that's a great question. So before we dig into the technical stuff, we found it's very useful to go through this mapping exercise where we basically sort of show our approach in a very simple way pertaining to our Belize application. And so most of you are probably familiar with Belize, but it's a beautiful place with the second longest unbroken reef system in the world. Rich diversity in terms of mangrove forests, archaeological Mayan ruins, lobster and other sorts of fisheries, as well as diverse habitats and world-renowned snorkeling and diving. The West Indian manatee has its home there. So it's a beautiful place that we're working in our tropical work. And so we're working with the Belizean government basically to develop a national integrated coastal zone management plan to understand how humans are using the coastal zone and how that affects the delivery of services. And so our goal there is to basically establish guidelines for sustainable development of the coastline for the long-term benefit of the people. So understanding how they use it and how we can sort of find these win-wins in terms of protecting key habitat and for the long-term benefit of these people. And so what we've done is we've used INVEST to identify different zoning schemes for the future and how that affects 3 different services: coastal protection, lobster fisheries, and recreation and tourism. So here's a diagram that we use to describe sort of our marine models and how they link together. It's important to realize that, of course, in addition to being linked to the terrestrial system, that they're all linked to one another. And the best example I can give you is you're seeing the services delivered at the bottom and the different models we have. But the best example I can give you is aquaculture. Somebody who works in aquaculture is obviously interested in harvested biomass and selling that and making money. But our approach does not ignore some of the negatives that come along with it in terms of waste. And so you could actually use results from our aquaculture model to understand how much, what kind of jobs and what kind of revenue you can expect, but also how that feeds into and affecting marine water quality and risk to habitat, and how those negatives trickle down into other services. So while you might be getting a lot from this service, you're also losing habitat, for example, that could be destroyed by poor water quality. If you don't have the habitat, it's not going to attenuate waves or slow their energy down or reduce their energy, and therefore you're not as protected from a major storm or flooding event. So this is sort of how we, especially in the marine work, how we link all of our models together, and it speaks to the game we're about to play and how they're all linked. In Belize, these are some of the human uses that they're concerned with or that they're looking to model with our models. Things like aquaculture, coastal development, agricultural runoff, fishing, recreation, and climate change. So what they've done is they've basically gathered an immense amount of information. Again, this is that stakeholder engagement process. Working with different coastal planning communities, they've gathered all this information that's occurring on the coastline for the current situation, what's happening right now. Seems like a fairly easy process. You can see it